Good afternoon, everyone. Thank you for coming to my presentation. And I would like to presenting my project for my final thesis on university with the title of Geomechanics Assessment of Shale Gas Reservoir, a case study of Pematang Formation and the Sumatera Basin. Okay. First of all, I would like to introduce a little bit about shale gas itself. The development of shale gas, of reservoir shale gas, are actually improving in the last 10 years. Most of them are located in America or in the western area. But lately we realize that in Asia itself, there's located a lot of total of gas itself from shale, and it triggered us to develop more about shale gas in Indonesia. In Indonesia itself, in West Sumatera, in central Sumatera, there's a lot of hydrocarbons located on the shale, which you usually call them as a source rock. Data came from Hollywood from 2016. The background of shale gas was a source rock with a high hydrocarbon content, but difficult to produce because they have a low permeability. In order to produce that, we need to create secondary permeability by using hydraulic fracturing. The problem is hydraulic fracturing needs further assessment, such as we need to know the value of the organic content from the formation, and we need to know the degree of the brittle index from the reservoir itself. Because if we fracking without knowing that, it can have high risk, because the fracturing itself needs lots of value of money, and we need to know that. Okay, the objective of my thesis is about identify shale gas characteristics based on the brittle index, the index of how easy the reservoir to be fracked, and using various data such as roll-off, cutting, including here, and seismic data, and then we distribute the brittle index property based on the 3D model and by the horizontal interpretation on the Pematang Formation. Then we evaluate by the geomechanics and geophysics data. Location of my target is located on the central Sumatera, near South Sumatra, located in Sumatera, this area, and the formation that I'm about to test is Pematang group with age about 8%, with a lot of limestone and carbonate shales, fine medium to green sandstone. And also in Indonesia, we know that shale reservoir is also type N included as a shale gas reservoir. Okay, this is my flowchart on how to assess the data. We usually using a 3 data such as seismic data, well data, cutting, and the most reliable data is cutting, because we see exactly the mineral from the stone. Because in order to calculate brittle index, we mostly known from the total of mineral from the stone itself, rock itself. We usually see the compound of calcite. More calcite, it means more brittle index. But the cutting data is only from a various depth. We cannot have a log data. In order to have a log brittle index, we need to compare with the brittle index from calculation from well off. So using 2 various logs such as pressure, PP and PS, compression and flow. And then from a 1D interpretation, we distribute with the seismic data after seismic interpretation, and coloration stratigraphy, then locate the high frequency index. Take this from data geochemistry. We take from various depths. We know that in depth of 6,200 to 6,850 feet, we get a high CRT, which is the first indication for shale gas itself, and with the RO percentage, we got this as early maturity. But this geochemistry evaluation is only used to justify that the area is interesting. Based on reference, we're using Western reference. In order to locate shale gas, we need to find good petroleum with a high CRT around 1 to 2%. In this summary, you can see that high CRT means high probability that the reservoir is going to produce a hydrocarbon. And also, maturity is also the important key. If not mature enough, it's really going to be difficult to fracture it later on. Based on the geochemistry itself, that at the depth that we're looking for, at the depth this one, is already categorized as a good shale gas. Although the differences between our reservoir and other reservoir is our reservoir is not mature enough. This is some calculation that I've done. Using from the log data, we're using compressional slowness and shear slowness in order to find model shale and Poisson ratio. That's the value that we're going to use to find the frequency index. This is a time slide of specific and location of well that I'm using. From model shale and Poisson ratio, we gather the average of frequency index that's located about this area. Oh, sorry. This is the area. Red area is red area is already less frequency index with the average is about 0.6 to 0.7. Okay. That's the Manggala to Pematang. It also justified by the follow shale gas. Follow shale. That's the location of this top shale and bottom shale that I'm targeting is also located as a shale. That's in shale. Okay. We're using a correction from the mineral, and we got the value from mineral and log itself is already corrected. Using the mu and lambda to justify the value itself, and here's the map and map. Okay. This distribute the continuity of the shale itself is stopped by the half dragon using a arbitrary line to locate the interpretation itself. And this is the frequency index map showing that the southern area from the well itself have a good frequency index, and also from parameter amplitude indicates that that's located shale. Okay, conclusion. There's some conclusion. Geomechanics analysis. The value is about 0.6. It's confirmed by mineralogy, and the high purity between 2.1 to 4.74, range 0.6 to 6.9 to maturity, and distribution high is matched with the distribution of shale rock. Okay. But this also this is just the data, but not have confirmed by the bore itself. Drilling. Sorry. Yeah. So I got the conclusion that sweet spot area is located at the southern of the well, as a suggestion for the further development of shale gas. Okay, thank you. That's it.
Thank you. I will open the discussion. So, questions? May I ask question? Yes. You mentioned about other your research and you compare with other research related and is there any research before Indonesia?
In Indonesia itself, there's lack of research about shale gas in Indonesia, but research in America itself is already been done so much. But we have a difficulty because we have a different oil system and different age, and that's why we cannot compare our reservoir with theirs. But as a reference, we're using shale gas value such as COC, we based on them. But sometimes reference from Western is not applicable in Asia because sometimes usually before the conventional reservoir with a low COC it's supposed to be not productive, but in Bali known some way ago some time ago the reservoir with low COC can produce even oil. That's why you cannot use it in America or Western.
Especially with the one that has already happened in Basin.
Yeah.
The war and then the north and the right and then
normal thing using a fracturing, hydro fracturing.
So any questions? Okay, if there is no more questions, so give him applause. Then next.